In this video, we'll talk about probabilities of permutations and combinations. I'll also cover a few examples with odds, but let's start by reviewing what combination permutations are. But before we do that, let's start by n factorial. What this actually means, it's 1 times 2 times 3 times 4 times ... times n. So for example, a 10 factorial would mean 1 times 2 times 3 times ... times 10, which means the product of first 10 numbers, and so on. Now let's start with the probabilities of permutations. So recall, permutations, very important is order matters. So what does it mean? For example, 1, 2 or 2, 1, 12 and 21 are two different numbers. Also, permutation of n taken k times is given by n factorial over n minus k factorial. So if you have to calculate permutation, this is what the formula looks like. So for example, John, Jerry, Mark, Andrea, Tina, and Scott come to a party. They arrive at different times. In how many ways can they arrive? In how many ways can John arrive first and Tina last? And find the probability that John will arrive first and Tina last. So let's discuss the first situation. In how many ways can they arrive? So we have 1, 2, 3, 4, 5, 6 people, right? So let's write 1, 2, 3, 4, 5, 6. Now the first person that arrives to the party can be John, Jerry, Mark, Andrea, Tina, and Scott. So there are 6 possibilities that one of them can be the first person. Now, once the first person is there are just 5 people left to come to the party. And then the next, once 2 people are already there are just 4 left. And then 3 times 2 times 1. So when we do the product, we end up with 720. So there are 720 ways these 6 people can arrive to the party. So John can arrive first, or Jerry can arrive first, or Mark, and so on. Now the second question, in how many ways can John arrive first and Tina last? So for example, we still have that 6 situation. John can arrive first. It would be one situation. He comes first and Tina comes last. That's one possibility. She comes the last one. Now there are Jerry, Mark, Andrea, Tina, and Jerry, Mark, Andrea, and Scott. There are these 4 people that can come to the party. Once Jerry came and Tina is the last one, 4 people can come the second one, right? The second person that comes to the party, it's one of these 4, Jerry, Mark, Andrea, and Scott. Once one of them came and it's at the party now, there are only 3 people left. And then there are 2 people left to come and then 1. So if we multiply all these possibilities, in how many ways that can be is 24. So there are 24 ways that John comes first, Tina comes last, and then the other ones can come at different times. Third part is that find the probability that John comes first and Tina last. So the probability is all the favorable possibilities. So in how many ways John can come first and Tina last to the party? 24. Over all the possibilities, all the ways they can arrive to the party, 720. So if we do the math here, if we cancel this, if we compute it, we end up 1 over 30 if we were to leave the probability as a fraction, or we can write 0.033 with 3 decimals. So while we didn't actually use the formula of the permutation, this is a situation where order matters because John coming first to the party and Jerry coming second, or Jerry first and John second, they are different situations. So we could have solved this in how many ways can they arrive. We could have said permutation of 6 taken 6 times, just because we have in how many ways 6 people can come to this party. So it's permutation of 6 taken 6 times, which is 6 factorial over 0 factorial. You probably saw in the literature that 0 factorial is defined to be 1, so times 720, so we get 720. Now let's take a look at probabilities of combination. So recall combinations, order doesn't matter. So in this case, an example would be John and Mary, or Mary and John are the same team. So if we have to select 2 people at random, if we select John and Mary, or we select Mary and John, it's order doesn't matter unless it is specified in the problem, a male first, a female second, or other conditions that make it order matters. So let's take a look at this problem. A box contains 12 calculators, 3 of which are defective. If 3 calculators are selected at random, find the following probabilities. All are defective and none are defective. So first of all, since there are 12 calculators and 3 are defective, we can immediately say that 9 are not defective. So let's find the probability that when you select 3 calculators, all 3 are defective. So the probability is given by all the possibilities that when you take 3 of them, all 3 are defective. Well, if 3 are defective and we remove 3, that's only 1 possibility over the total number of possibilities to select 3 calculators out of 12, which is combination of 12 taken 3 times. So if you use the calculator I showed you in one of the previous videos, we get 1 over 12 combination of 3, that equals 220. We leave the answer as a fraction. We cannot simplify it anymore. Now the second one is probability that none of the 3 are defective. So now the probability is given by, well, at the denominator we still have 12 taken 3 times, but at the top I want to write all the possibilities of drawing no defective calculators or selecting. So that would be combination of 9 calculators are not defective, and we take 3 of them. So then if we do the math, we get 84 out of 220. If we divide by 4, we get 21 over 55. And let's take a look also at odds. So odds in favor of an event E, it's given by the formula probability that event E occurs over probability of event E doesn't occur, and odds against the event E are probability that event E doesn't occur over probability that event E occurs. So let's take a look at this problem. The odds in favor of a player making a shot are 20 to 8. What does that mean? It means that out of 28 shots, 20 are making the shot, they make the shot, while 8, they don't make the shot. So when we have to find the probability that the player misses the shot, Well, this is given by the probability that this is given by the number of times he misses the shot. Well, that's 8. And then the total number of shots, 28. So if we divide by 4, we get 2/7. What if we had to find the probability that he makes the shot? Well, that would be the number of times he makes the shot, which is 20, out of the total number of times they shoot the ball. So when we divide by 4, we get 5/7. And you can notice, if you take a look at what we got, 2/7 plus 5/7, it's 7/7, which is 100%. So he either makes the shot or doesn't make the shot, right? Those are the only possibilities. Let's do an example now that says, if you are dealt 3 cards from a deck of 52 cards, find the probability that all 3 are 10s. So let's solve this problem using 2 methods. Method 1. Well, let's find the probability that the first one is a 10, and the second one is a 10, and the third one is a 10. Now, the probability that the first card is a 10 is 4, because there are 4 cards that are 10, out of 52, because that's a total of 52 cards. Times, right, we connected the word end with times. The probability that the second one is a 10, given the first one was a 10, it's 3, because we have left just 3 10s now, and 51 cards in total, because we already removed 1 card from the packet. Times, now the probability that the third one is a 10, given the first 2 were 10, it's 2, because there are just 2 cards of 10 left, over 50. So if you do the math, you end up with 24/132,600, which simplifies to 1/5,525. Now the second method is the probability that all 3 are a 10, 3 cards of 10. Well, let's discuss the denominator. The denominator is all the possibilities all the combinations that we have from drawing 52, from drawing 3 cards out of 52. It's combination of 52 taken 3 times. And now all the combinations that we have for drawing 3 cards of 10 out of 4, it's combination of 4 taken 3 times. So when we solve this, we end up with 4 factorial over 1 factorial times 3 factorial, and the denominator is 52 factorial over 49 factorial times 3 factorial, and if you do the math, this cancel with this, 1 factorial, it's 1, so we end up with 4, which is 4 times 3 times 2 times 1, but 1 doesn't make much of a difference, and 52 factorial over 49 factorial, it's 52 times 51 times 50, which is exactly the fraction that we had before, which is 1/5,525.